So in this video, we're going to talk about how you can write square root equations using Desmos. So what if you're given a table of values and asked to write a square root function that best models the data set? Well, if you look in the Desmos regression menu, notice that square root functions are not a choice there. Okay, so we can't get Desmos to directly write a square root function for us, but we can use Desmos to help us figure it out. We're just going to have to do a couple extra steps. What I want you to remember is that Desmos will do quadratic regressions, right? We had a whole lesson on this a few days ago. And so we can actually find a quadratic equation using Desmos. I also want you to remember what we talked about in the inverses unit, and that is that quadratic functions are the inverses of square root functions. So if we have a quadratic function, we can find the inverse, which is a square root function, by replacing f of x with y, switching x and y, and then solving for y. Okay, and then we can use function notation to represent our answer. Also remember the relationship between a function and its inverse. Remember, if a point xy is on the graph of an original function, the point yx will be on the graph of the inverse, right? So remember, you just basically take the x and y and then reverse them when you're finding the inverse. So let's put all of this together to get an idea of how we can use Desmos to write square root functions. We'll be given the table of values that's on the square root functions, right? But we need to find the quadratic that represents its inverse. So in order to do that, we'll have to switch those values and then work backwards after finding the quadratic equation to turn it into a square root equation. Okay, so here's the process. We'll start off by creating a new table of values for the inverse by switching x and y. Then we'll enter this table into Desmos. Then we'll have Desmos do the quadratic regression, okay? And then that function will be the inverse of the function we're looking for. So we'll need to find the inverse of the quadratic by switching x and y and solving for y. And then we can use function notation to represent the square root function that we get as the result. Another thing that we'll be using a lot of as we work on turning that quadratic into a square root is we're going to be doing completing the square. Remember, we did completing the square back in the quadratics unit. Remember, we move the constant term away, and then we add this b over 2 squared right here in order to turn this into a perfect square trinomial. And that will allow us to rewrite this in factored form as x minus 3 squared, right? Because this is a perfect square trinomial. Okay, so we're going to be using this technique again today as we work through turning our quadratics into square root functions. So now let's look at an example. So it wants us to find the square root function that best fits this table of data. So remember, I can't find the square root function directly from Desmos, but I can find the quadratic that represents its inverse. So in order to do that, I need to start off by switching my x and y values. Okay, so I'm going to recopy everything that's x in my y column. So I'm going to write 3, 4, 7 here. And then everything that's y is going to go in my x column, right? Because that's going to be the coordinates on the inverse. So now I can go to my Desmos and then add a table. And then I'm going to type in the values in the inverse function. Okay, so I'm going to do 4, 3, 5, 4, and 6, 7. And now I'm going to ask Desmos to do a quadratic regression. Okay, so I'm going to choose quadratic. You can see here it gives me the quadratic function, which is x squared minus 8x plus 19. Okay, and that's equal to y. Well, what I need to do now is I need to turn this into a square root function, okay? So to go ahead and turn this into a square root function, I'm going to start off by switching x and y. So I'm going to turn this into y squared minus 8y plus 19 equals x. Well, remember, now I need to work on getting y by itself, okay? So in order to get y by itself, I'm just going to put all my y terms together and move everything else away. So what I'm going to do now is subtract 19 from both sides. Okay, so I subtract 19 from both sides. So I have y squared minus 8y equals x minus 19. And since I'm actually out of room, I'm going to go to the next slide. I'm just going to recopy what I had, y squared minus 8y, x minus 19. And so what I need to do now is to find a way to group these y terms together. Okay, so if I get all my y together, I can actually go ahead and solve for y. I can't solve for y when I have it in two terms like this. So what I'm going to do now is I'm going to use that technique, completing the square. So remember, what that means is I'm going to take that 8, okay, so that negative 8, I'm going to divide it by 2, and then I'm going to square that. So that's basically telling me to have negative 4 and then square it, which is equal to 16. Okay, so I'm going to take that value of 16, I'm going to add it to both sides of my equation. So I add it over here, and then I also add it over here. Okay, so when I do that, I get y squared minus 8y plus 16 equals x, and then minus 19 plus 16 gives me minus 3. Okay, well, now what happens is over here, this is now a perfect square trinomial. Okay, so what it means is I can take that value b divided by 2, okay, which remember that was negative 8 divided by 2, and then I can write this as y plus b over 2. So I just put this as y minus 4, and then all of that squared is going to equal this trinomial right here. Okay, so you can actually try it out and see that it does in fact work. Y minus 4 squared is equal to y squared minus 8y plus 16. Well, the benefit of doing this is now I have all of my y just in one term, right? So I have y minus 4 squared equals x minus 3. This is going to make it easier for me to solve for y, right? Because now what I can do is I can take the square root of both sides. Okay, so I have y minus 4 is equal to the square root of x minus 3. And then now in order to solve for y, all I need to do is add 4 to both sides. Okay, so remember when I have this, I'm going to have y equals the square root of x minus 3. And then that plus 4 is going to go on the outside because I added 4 after taking the square root. Okay, so that original square root function that I'm looking for, that's going to be the square root of x minus 3 plus 4. Okay, so that's all the steps you need to do in order to find a square root function using regressions in Desmos. You have to first find the quadratic that represents its inverse, right? That quadratic was x squared minus 8x plus 19. And then you switch x and y, and you go ahead and find the inverse in order to find that square root function. So now you can pause the video and try doing this example on your own. So here, once again, we have another table of data. So remember, the first step is to switch x and y so that we can find the quadratic, okay? So I'm going to go ahead and switch x and y. So I have negative 5, negative 4, negative 3, negative 2 as my x values now. And then I have negative 2, negative 1, 2, and 7 as my y values. So now I'm going to enter this new table into Desmos. So I'm going to go ahead and type it all in. And what I'm going to do now is do add regression and then choose quadratic. And so you can see here it gives me the quadratic function y equals x squared plus 10x plus 23. Well, remember, I'm not looking for a quadratic. I need to find the square root function. So I'm going to now switch x and y so I can find the inverse. So I have x equals y squared plus 10y plus 23. Okay, well, I want to get my y terms by itself. So I'm going to go ahead and subtract 23 from both sides. So when I do that, I get x minus 23 equals y squared plus 10y. Okay, so I'm going to go ahead and go to my next slide because I'm almost out of room. So I have x minus 23 equals y squared plus 10y. Okay, so now I need to take this 10. Okay, I'm going to do 10 divided by 2, and then I'm going to square it. 10 divided by 2 is 5. 5 squared is equal to 25. So I'm going to go ahead and add 25 to both sides. And when I do that, I get x minus 23 plus 25 gives me plus 2. So I have x plus 2 equals y squared plus 10y plus 25. And so remember, I need to take that b, which is 10, divided by 2, and remember that equals 5. So when I write this as a perfect square, I'm going to write this as y plus 5 squared. Okay, y plus 5 squared is equal to y squared plus 10y plus 25. And then on the left side, I still have x plus 2. Now that my y is only in one place, I can go ahead and solve for y. I'm going to start off by taking the square root of both sides. So when I take the square root of both sides, I get the square root of x plus 2 equals y plus 5. And now in order to get y by itself, all I need to do is subtract 5 from both sides. So when I subtract 5 from both sides, remember that 5 is going to stay on the outside because I subtracted it after taking the square root. And so I have the square root of x plus 2 minus 5 equals y. So that means that square root function that I was originally looking for is equal to the square root of x plus 2 minus 5. Okay, and that's the value of f of x. So remember, using a table of values, you can write the equation of a quadratic function using quadratic regressions on your calculator. So you can use this idea to write the equation of a square root function. All you have to do is find the inverse function, which is a quadratic, and then find the inverse algebraically in order to find the square root function.